Listen-only mode.
To today's webinar on mycotoxin testing and survey results. Hosted by BIOMIN and Romer Labs. My name is Ryan Hines, and I'm the editor of Science and Solutions. Joining me today are two experts, Simone Schaumberger, Product Manager at BIOMIN, and Philipp Gruber, Product Manager at Romer Labs. Welcome to you both.
Hi.
Now, both companies are part of EBA Group and approach the topic of mycotoxins from somewhat different angles. BIOMIN offers cutting-edge mycotoxin deactivating feed additives. Romer Labs specializes in innovative diagnostic testing for mycotoxins and other analytes. Now, I'd like to remind you of those of you listening that this is an interactive, live webinar. In the lower right hand of your screen, you can enter questions for our speakers. Some questions and answers may be shared with the entire audience. This chat function can also be used for the Q&A session later on. In addition, you, the audience, can also vote at several times throughout today's session. When I announce a poll question, you'll have the opportunity to provide your input in real time, and I will announce the aggregate results of that poll. Let's start now with our first poll question. So our first poll question is, have you encountered a problem with mycotoxins in the past 12 months? The options are yes, no, or maybe. And while our audience members are selecting their answer, Simone, could you just remind us of the importance of mycotoxins to the feed and livestock industries?
So first of all, thank you, Ryan, for your kind introduction. Basically, it's a fact that mycotoxins cost the livestock industry billions of dollars each year. And this is mainly due to the fact that on the one hand, commodities experience a decrease in quality when contaminated with mycotoxins, and on the other hand, that productivity of the animal decreases in the presence of the secondary metabolites of fungi.
All right, thank you for that, Simone. We're now going to close the voting. It looks like everyone has had an opportunity to answer, nearly everyone, and I'm going to provide the results. 61% of you have said that yes, you've encountered a problem with mycotoxins recently. We have 19% who say no, it's not an issue, and 20% who think, yeah, maybe it could be an issue. So those are interesting results. And you know, Simone, the 2015 BIOMIN mycotoxin survey covers over 8,000 samples of finished feed and single raw commodities from 75 countries across the world. Do these results also indicate a mycotoxin problem?
Yes, of course. This is exactly what we experience in our annual survey.
Can we click? All right, so we're having an issue. Moving to our next slide. In the meantime, Simone, why don't you tell us what the results show?
As Ryan already mentioned, we are dealing with over 8,000 samples in 2015, and this meant there were over 31,000 single analyses done in 2015. These figures you now see on the screen represent the worldwide mycotoxin distribution, including risk threshold levels represented by the dots. The bars show the percentage of samples contaminated with the different mycotoxins. For instance, we have 73% of deoxynivalenol contamination worldwide, represented by the gray bar. And in nearly 60% of samples, fumonisin and zearalenone were detected, as shown by the orange and red bars. Additionally, as mentioned, the dots within the bars display the occurrence of mycotoxins above the threshold levels, which are based on the most sensitive species. So, if we take Dawn as an example, we see that 77% of samples that contain this mycotoxin pose a risk to piglets and sows, which are the most sensitive species to deoxynivalenol. In the table below the graph, we see the average concentration of each mycotoxin and the highest single occurring concentrations. In general, we observe once again that deoxynivalenol and fumonisin pose the highest risk to animal health. Taking a look at selected commodities in grains such as wheat and barley, we observe high levels of deoxynivalenol contamination, again followed by zearalenone and fumonisins. A high percentage of maize contains as well again deoxynivalenol, fumonisins, zearalenone and aflatoxins above the risk threshold levels, which is reflected again in maize silage, which is displayed here on the right side. Also, high protein components of the diet, such as DDGS, displayed on the left side here, can be a high source of mycotoxins due to a concentrating effect of these substances in such byproducts. But what does this in general mean in terms of contamination in finished feed? On the left-hand side, we see the worldwide results for finished feed, but I want to give you a practical example using a typical Central European broiler feed composition. When we take the average contamination levels of the worldwide results, and even if we only use 60% of high-risk maize and 30% of the protein source soy, the total load of deoxynivalenol and zearalenone would exceed the risk threshold levels that would cause various symptoms in broilers, such as reduced performance and an increase in susceptibility to diseases.
So what does all of this mean for livestock producers in various regions across the world?
So that's a good question. So let's have a closer look. Let's start with Europe and Africa. These figures you see now on your screen give an overview of the percentage of samples above risk threshold levels in Europe at the higher screen part, and Africa represented by the different bars. The maps beside show the origin of the samples. In Europe, generally, a higher number of samples have been analyzed for various mycotoxins compared to all other regions. But in general, again, we observe that deoxynivalenol poses the highest risk to livestock, shown by the gray bars in Europe and Africa. This is a reflection of what we have observed in the previous slides on a worldwide basis as well. Now let's come to the results of Asia. In Asia, over half of all samples contain deoxynivalenol at levels that pose a health risk to livestock. More than 1/3 of samples are contaminated by zearalenone at a concentration of over 50 ppb. Asia faces the highest threat to aflatoxin-related risk to livestock. And now let's come to America. As in all regions, deoxynivalenol also poses the highest risk to livestock in Northern America, with more than half of all samples above the threshold level. Compared to that in South America, 25% of samples exceed the risk threshold for deoxynivalenol, and the main difference here is the high risk that is posed by fumonisins, with 43% of samples above 700 ppb.
All right, so for everyone listening who would like to know more about the threat from mycotoxins, what resources are available?
Yeah, if you would like to learn more about mycotoxins in your region, we have developed a special app with the latest finding updated on a quarterly basis. It contains specific information per species, region, and per mycotoxin. Additionally, a report on the new detailed data on the complete mycotoxin survey 2015 will be released after the webinar.
Thank you for that, Simone. Now, let's take a moment for our second poll question. Those of you listening have an opportunity now to provide your feedback on the following question. How do you test for mycotoxins? 1, on-site testing. 2, external analytical service. 3, we do not currently test for mycotoxins. Or 4, not sure. Go ahead and take a moment to select the answer that best fits your current strategy for mycotoxin detection. We have those results coming in real time. We have over 70% of the vote registered so far. Please go ahead and continue. We're going to leave it open for just another moment as those results come in. And we have 80% of votes. All right, it's looking like we're going to call it here quite soon. Okay. Thank you. We're going to close the vote now, and I'm going to announce the results of poll question 2. So this is interesting. We have 27% of you that said you use on-site testing. 56% use an external analytical service. 13% say that you do not test for mycotoxins, and 5% are not sure. Now, Philipp, how do those results compare with your experience in the field?
First of all, hi again. Well, Analytical Service is available for many, many years now, and I think customers still appreciate the reliability of this reference method offered in Analytical Service.
Now, can you tell us more about the available test methods, perhaps the differences between on-site versus external services, and how to choose the right one?
Oh, sure. Your first step would be to decide whether to send your samples to an analytical service lab, or you want to perform the testing by yourself on-site. So we've put 3 things here, 3 parameters, which you have to consider. The first would be the throughput of testing you actually have. If you have a high throughput, it might be worth to set up your on-site testing. But if you are only testing occasionally, it might not be worth it. So you rather would send your samples to an analytical service lab. Second thing would be the time to results you actually can accept. So if you need fast results, and if your decision making really depends on it, you have no choice. You have to go for on-site testing, because these are really the methods which give you results within 1 hour, for example. If you can wait for 1 week, you can send your samples in. It would take about 1 week from sending the samples in until you receive your results from an analytical service lab. And the third part, or the third thing, would be the quality of your results you want to have, actually. Bear in mind that on-site methods are mostly screen methods, so their results variability is about 20 to 30%. On the other hand, analytical service gives you the opportunity to choose a reference method, and those reference methods are considered more reproducibility.
Okay, so what on-site testing options are available?
Well, the most popular on-site methods are strip tests and ELISA tests. They are both antibody-based methods. And if you look at strip tests, for example, those tests really are made for immediate decision making, and if you have a small sample number. For example, imagine a truck is waiting at your gate and you have to decide whether to accept or reject a lot it carries. You would go for strip test, because strip test would give you results within 10 minutes, and this would help your decision making a lot. If you have more than 6 samples at a time, if you want to test for more than 6 samples simultaneously, you would go for ELISA, because ELISA is then a much faster method per sample, also get cheaper, and you can test for up to 44 tests simultaneously. So with analytical service, if you want to send your samples in, you still have to make decisions here. It's not done with just sending the samples away. So here you would have to decide which methods should produce your testing results. The first you see here is the ELISA method. It's the same as we presented just before with the rapid tests, same kits here, but they are now produced, or they are now conducted by Analytical Service labs. It's the cheapest method here. You have restrictions. You have only one target, one analyte with one test to run, and you have the accuracy of a screening method. The other two we see here is HPLC and LC-MS. Those are both considered reference methods, and their advantage over the screening method, the ELISA, is first of all you have more runs at a time. With HPLC you can have multiple targets at a time. You can choose for packages you want to analyze from down and so on. With one run you can have that with HPLC. And with LC-MS, with the multi-mycotoxin method, you can even run up to 18 mycotoxins with one run. The last point would be the accuracy. Both HPLC and LC-MS are reference methods, less variability, more reproducibility. If you cannot decide whether to choose HPLC or LC-MS, it really comes down to cost at this point. So you would get a more whole result with LC-MS. It's therefore a bit more expensive as well, but you have the advantage that the results come from an accredited method.
All right. So thank you for that overview of both the on-site options and the external analytical service. So does this mean that I could use rapid tests to check finish feed for mycotoxins?
Our recommendation for this question is always that you should monitor the input and the output of the finished feed production. So you take rapid tests to really nicely screen your incoming raw material that you will use further on in the feed production. Always keep in mind that costs increase when the contaminated product moves downstreams. And the best mycotoxin strategy is to measure your contamination, to catch your contamination before it hits the mill. As a next step, your raw materials go into the mill, and then you will have two options depending on the amount you have. You can apply analytical service, you can send in your finished feed samples, but you also can apply rapid methods. So if you have small quantities and your feed recipes vary, you would send in the samples. But if you have bigger quantities and your recipes doesn't change that much, you could go for customized protocols for rapid tests and then apply really rapid tests for finished feed as well. So what do we mean with customized protocols for rapid tests? Every time you use a rapid test, you have to take the correct protocol for the given commodity, for the given agricultural commodity. We have here on the slide with two really widespread commodities, corn and soy. So what is the difference between them? They look different, you can see that, but there's also difference in their nutritional composition. For example, if we go for carbohydrates, we have high carbohydrates content in corn. That's a mean, a rough number, about 70%, and a very low carbohydrate concentration or amount in soybeans. It's vice versa with proteins. Low protein content in corn, high protein content in soybean. We have about the same content of fats, but still keep in mind that the kinds of fats and proteins and carbohydrates are also different within these agricultural commodities. So what does those commodities do? Or those components of those commodities do? They can interfere with the test reaction of your rapid test. As a result of this interference, you could get overestimations or underestimations of your test results. It's also possible that those components block your reaction at all. And this whole thing bears the risk that you get false positives, false negative results, and we all know that it's a severe problem. So to compensate this influence, you need to apply the correct protocol, and there are many specific protocols, customized protocols or commodity-specific protocols available. There's one for corn, for example. There might be another for soybeans. You need that because, or what would be the adjustment of these different protocols? If you have overestimation, you might have a different dilution factor, for example. So if we're now talking of feeds, can we test finished feed with rapid tests? The tricky part is that the feed composition from raw commodities vary with market price, they vary with season, they vary with geographical origin. So you have a huge variability with your feed recipes, with your feed composition from different agricultural raw commodities. So it's not at all possible that you have one customized protocol, one protocol for all kinds of feed. There's not one feed. So that's why you would have to go to a customized protocol of your feed recipe.
Thank you, Philipp. And just for the audience, how does one go about getting a customized or a tailored protocol in this case?
Romer Labs, for example, offers this as a service. It's called Commodity Validations, and you can get it in this way.
All right. Thank you for that, and thank you for the overview on the raw materials and finished feed testing. Let's shift gears a bit and talk about reliability. So with all of these different methods, how reliable are mycotoxin test results?
I have one slide here, which is very interesting. It's remarkable. This slide shows the total error of mycotoxin testing, for example. And you see really the path from taking a sample until receiving the result of your analysis. And what you can see here is that the analytical error is quite small. We talked about rapid tests, reference tests. This is really a quite small error in comparison to the sampling error. So if you don't manage to make proper sampling, it doesn't matter what analytical method you would apply, you would get wrong results. And well, for example, there are several numbers out there. One is that about 76% of the total error is contributed by the sampling. So why is that? Well, the first thing is that we have to measure mycotoxins at a very, very low concentrations. Regulations are very, very low. They are usually in the parts per billion concentration area. And just to get a right idea of this level, this is 1 second in 32 years. So it's very, very small amount. Second reason is the uneven distribution of mycotoxins within a field, actually, or within a lot. So you could have 1 year contaminated in an entire field, and that is subsequently reflected in your lot as well. You could have a lot which is fine at all, and then you have a small hotspot of mycotoxins with high concentrations. We have one table here from the mycotoxin survey showing 6 Corncobs from the same field, just 5 meters, taken from 5 meters apart. And you can see that the contamination levels vary a lot.
Right. So what can be done to mitigate this, to reduce or even eliminate sampling error? And do you have any tips for us?
I have some rules of thumb. There is a EU recommendation out there. Just a small part of a big recommendation is shown on this slide. If you, for example, take 50 tons of cereals, if your lot has this size, take 10 to 100 incremental samples of about 100 grams each. You would reduce your total, or you'd reduce your sampling error if you increase your sampling number, if you increase your sampling size, but also if you apply a finer grind, because then you would get an even better homogenization, which is quite important. We have a sampling guide, BIOMIN and also Romer, offers the sampling guide to for you, actually for customers, to find the best sampling solutions for them. There's also a software tool I want to point out. It's supplied by the FAO. It's a really nice tool to get your best fitting sampling plan, which fits best to your expectations of confidence values and also of the raw commodity you want to test for.
Great. So let's go back to our audience now for our third poll question. This is your opportunity to provide input on the following. In the past 12 months, which mycotoxin mitigation methods have you used? And here we should have multiple choice is allowed. You can choose the answers that fit your situation best. The first is a mycotoxin binder added to feed, a multi-strategy mycotoxin deactivating feed additive, good quality control and feed management. Mycotoxins are not an issue for us, and currently looking for a solution. Please go ahead and provide your feedback. We have those results coming in right now. We're going to keep the voting open for about a minute. And as those results come in, it looks like we have some different strategies that are coming to the fore. We have more than half of you participated in the vote. Thank you for those that have voted. We're continuing to collect feedback. The poll is still open. And right now, the two primary options look to be the first one, so the mycotoxin binder, and the third one, the quality control and feed management. It looks like the majority of you have had the opportunity to vote. So now we're going to close the voting. Thank you for your participation. And I will now announce the poll results. So bear in mind, these numbers will exceed 100% because multiple choice was allowed. For our first option, it looks as though 40% have used a mycotoxin binder added to feed in the past 12 months. 27% have used a multi-strategy mycotoxin deactivation feed additive. 45% for good quality control and feed management. 11% say that mycotoxins are not an issue. And 15% are currently looking for a solution. So that's interesting. So perhaps one of those other options could be interesting for you. Simone, what do these results tell you? And is one of these strategies the right approach?
Okay, thank you for this question. It's a really interesting outcome, especially that most of the people still use binders. But to give you an explanation on that, I want to start from a little bit a different point. Because we know that due to the different structures you now can see on the screen of the major mycotoxin groups, that different deactivation strategies have to be applied or are required to have an efficient deactivation within the animal. To get a step further, I want to summarize those strategies for you, which include 3 different approaches: the adsorption, the biotransformation, and the bioprotection. So let's start with the adsorption, because an efficient and specific adsorption is important for the elimination of adsorbable mycotoxins such as aflatoxins by selected mycotoxins. The next strategy is the biotransformation that offers scientifically advanced solutions available to counteract non-adsorbable mycotoxins such as trichoticins, the most common one, the deoxynivalenol, the fumonisins, but also the cerelenol. And here, the toxin is converted into non-toxic, environmentally safe metabolites in the digestive tract of the animal. And last but not least, to close the strategies, we have the bioprotection, which is by different plant materials, giving immune and liver support, and therefore counteracts the harmful effects of mycotoxins within the animal.
Okay, so of these 3, how do I choose the right product or the right strategy?
Yeah, it's a very important question. Thank you, Ryan. So Once you have identified your problem by conducting feed analysis, because this is always the first step when we talk about mycotoxin control, you should choose a product which is efficient and safe for your animal and is fitting your needs, of course. So give you an example, Mycofix is the only worldwide feed additive with the 3 EU authorizations for mycotoxin deactivation, which fulfill the strict requirements on identity of the components, safety, and efficacy, which was proven by standardized processes. The efficacy of the different components has been scientifically proven not only in vitro tests, but also in vivo, using recognized relevant biomarkers, which were also developed within this authorization process in a long-year research program. These 3 components included the selected BIOMIN, which you see here at the top, for absorption, the patented biological component BIOMIN BBSH797, and the specific pure enzyme, FUMzyme, which are responsible for the biotransformation.
Thank you for that, Simone. So to tie in detection and solution on the topic of mycotoxins, let's take a case where, let's say, sampling is done correctly. A mycotoxin screen report shows no or low contamination. Does that mean that there's no cause for concern?
No. As you know, and it's always reported again and again, there is at least no safe level for mycotoxins on the one hand, and we always have their interactions. But let me give you an example to see what this could mean in the field. Here you see the example of a dairy farm which had about 100 Holstein cows, and the main problems which were observed on the farm were losses in milk production and increase of somatic cell count, as well as a loss in performance. All these symptoms might be caused by deoxynivalenol or by the multiple contamination with mycotoxin within the TMR. But as you can see here at the bottom, analysis of the major mycotoxins showed a very low contamination, but however the farmer still was concerned what could be the problem, or is there still more to know about feed quality. Therefore, he went a step further together with our BIOMIN team, and he did some routine analysis, the so-called Spectrum 380, which shows a complete picture of the total mycotoxin load in a sample by measuring over 380 secondary metabolites of mycotoxins and their metabolites, including the masked and the emerging mycotoxin, using again, as we have heard before from Philipp, the LCMS-MS method. This service was developed in a cooperation of BIOMIN with the leading institute for mycotoxin analysis, the IFA Tulln in Austria. With this method, we then had a closer look, and it was very interesting to see that when we look at the different metabolites of serralinon, we could see when we add the masked mycotoxin, the serralinon sulfate, with over 120 BPB, we come to a total sum of 200 BPB of serralinon in the sample. But it goes a step further. If only DON would have been analyzed, the result would have been about 300 BPB of DON, and we know cows are said not to be really very sensitive to this mycotoxin. However, if we sum up all the different beta-trichotesines and metabolites, we see a different picture. The masked DON, the so-called DON3-glucoside, constitutes of 50 ppb, and more importantly in this case was the so-called nivalenol, which was present at over 1 ppm within the feed sample. And this is then 3 times higher than the deoxynivalenol alone. And from research studies, we nowadays know that nivalenol is said to be even more toxic than deoxynivalenol alone. A similar picture we also see when we look at the total sum of fumonisins, because a lot of regular methods only cover the fumonisine B1. But when we take the total sum, we also doubled the amount of fumonisins in the feed, and we had over 800 ppb of fumonisins in the total feedlot of the TMR. So I think this is a very nice example to see how important the different steps are with the mycotoxin risk management. And as we always say and promote, there is no safe levels, but it's important to include a proper, correct sampling, the right method for your farm or for your needs, and at the end to use an efficient mycotoxin deactivation method.
Okay, well, Simone, thank you for that. That's certainly an eye-opener in that case. Now, just a word to recap some of the tools that we've seen for the audience. These have already been mentioned by each of you, Simone and Philipp. The MycoFix app and the MycoFix video are both available on biomin.net. We also have the sampling guide, which is available on romerlabs.com, and the FAO mycotoxin sampling tool on their site. At this time, we're going to open up the session to questions from the audience. We'll field a number of questions today. You can take the opportunity to enter those now in the question function on your screen if you care to pose a question. We've also collected quite a few questions from the audience upon registration. So when you registered, we've collected questions as well. And let's start with our first one. Philipp, here's one for you. What is the difference in terms of the analysis results between ELISA tests and reference method HPLC?
Okay, I'll start with, to understand the results, we have to go a little bit into the technologies. I will simplify a lot, so I will keep short. Let's start with HPLC and ELISA. They're really completely different technologies, different methods. ELISA, for example, uses proteins, antibodies to catch the analyte. In our case, this would be the mycotoxin. And this catching, this reaction, then gives a signal. This signal can then be measured in some way. With HPLC, it's the same with LC-MS. The C stands for chromatography. So you that means that you basically send your sample through a column, and within this column you would separate your analytes, in our case mycotoxins, and those separated analytes can then be detected by some kind of detector, for example UV-Vis, a light detector, analyte by analyte. So coming from these different approaches, you have to understand, or it has to be understand, that those different approaches won't never give the exact same result at all. So you would always have a slightly different result, but in kinds of reproducibility, reference methods like HPLC or LC-MS will give you better performance.
Okay, yeah. Thank you for that. We have another question coming in. This one has been asked several times already. For Simone, what can you tell us about the effects of mycotoxins on vaccine efficacy?
Yeah, well, this is a very important to be addressed because we know, or it's discussed on a regular basis, that mycotoxins interfere with immune cells, and immunity is very important when we talk about vaccination. And we know that depending on the dosage and the type of mycotoxins, for example, trichoticins and fumonisins are very well known to interfere with these immune cells. They will impact the immune system, as especially trichoticins affect the high-dividing cells. We see a major impact in the course of lowered antibody development after vaccination when mycotoxins are present. But a big issue here is, so even if you don't see the clinical symptoms, because this is something which is happening below the surface, you might not experience immediately problems in your animals, but this is then when there is maybe another trigger factor, and then it goes boom, and then you have the biggest issue. Therefore, when we talk about vaccination and immune system, prevention is one of the major things I really can recommend in course of mycotoxin contamination.
Okay, thank you for that, Simone. Let's take another question from the audience. All right, now having a look here, we have another one for Philipp. So again, on the detection topic, are there quick tests for Dawn and Zen for finished feed?
We have performed validation studies on our ELISA kits. We have several studies there for certain feed recipes. Those cover all ELISAs we have, and we have ELISA, quite big ELISA portfolio covering almost all regulated mycotoxins. Also want to point out that we have quite nice strip test portfolio covering Dawn, Fum, and AFLA tests. So yes, we have successfully validated ELISAs on mycotoxins like Dawn and so on.
Okay, that's good to know. Let's dig a little bit more into these questions that are coming in, and thank you for all the questions. It looks like we will not have time to get to all of them today, but we will come back to you with answers to each of those questions. Simone, here's one that we've seen repeatedly. This is sort of the proof question, you know. So you have a mycotoxin deactivating product like MycoFix. How do you evaluate that it's really working? How do you see that it biotransforms mycotoxins in vivo?
Yeah, well, this is a history. So checking for an effective product is really challenging, and because how do you show that the biotransformation is effective in the animal? So this is really a great challenge, and therefore a lot of efforts were investigated and necessary for BIOMIN and also with cooperation to establish defined and really controlled biomarkers to show that the biotransforming effect of enzymes or microbial producing enzymes are working in vivo. In course of the authorization process of BIOMIN, BBSH and FUMZYME, biomarkers had to be found, developed and proven to be effective in vivo. But this means that we had to really look what is happening with the mycotoxin in vivo. For example, what is the mode of action in the animal? Where do we find the mycotoxins? Is it more that it goes via excreta? How is it biotransformed within the body? And then define those which we can measure and prove this then within very controlled and scientific setups to really say we find or we show that the metabolites which are produced within this biotransformation are effective and are non-toxic to the animal anymore. So on the one hand, we showed that it's that the metabolites are produced in vivo. On the other hand, we also had to show that these metabolites have no cytotoxic effect within the animals. So this is a very complex setup, and we are happy that we could do this proof for our defined products.
Okay, great. Another question from the audience, and let's see here. So the topic is emissions or environmental concerns. So nowadays industries require the use of fewer solvents. I guess a more environmentally friendly solution. Philipp, it sounds like that's the topic of green testing. What can you tell us about the importance of green testing and the solutions?
Well, when you want to test for mycotoxins in agricultural raw commodities, you have to extract your mycotoxin into a solution from corn, for example. And as many mycotoxins are not water soluble, you need some kind of solvent for that. So what was done traditionally is that organic solvents were used for that purpose, like methanol, ethanol, acetonitrile. And the problems with the solvents is that they are hazardous. So they bear health risks for the operator, but also they bear risks for the environment. So you have to dispose them properly. Also an effort an operator and laboratory has to take. So what was done with strip tests in the last years was to apply water extraction. So you wouldn't need organic solvent to extract a mycotoxin, but you would take water in combination with some kind of extraction buffer, which is friendly to the environment and also friendly to your health. There's no health risk included. Romer Labs offers such a water extraction with AgriStrip Vortex for now, and well, our results are great on that.
That's great to hear. And you know, sustainability, of course, being a big topic for any business and industry. We'll look to further developments on that front. We have another question here regarding poultry. Okay. So the question is, right now we are screening for AFLA, T2, and ochratoxin. It is suggested to screen for Zen and deoxynivalenol. And is it? All right. So is it suggested to screen for these others, Zen, Don, and fumonisin? Simone, what do you think?
Yeah, good question. But when we remind of the slides I showed, and we still see that on a worldwide base, deoxynivalenol and zearalenol are the major occurring mycotoxins, and they are often co-occurring, as we know. It's really highly recommended to also screen for zearalenol and deoxynivalenol as well as fumonisin. Although maybe poultry won't be the most sensitive species compared to swine, it's still the big issue that levels increase on the one hand, and that the co-occurrence might lead to more symptoms within the animal.
All right. That's great. We have a couple of questions here regarding, let's say, nutrition and feed. So, can a mycotoxin deactivating product diminish the vitamin or nutrient content of feed, and is that something to look out for?
So it's a very, very important question, because when you choose a mycotoxin deactivating product, or in this case a mycotoxin binder, it's very important within the evaluation process of a specific bentonite to check the specificity, so it's really only binding mycotoxin, and to check that it's exclusively only binding toxins, because it has to be proven that vitamins and nutrients are not bound within a bentonite. So this often can also be on a dosage-dependent fact, but we made the experience with our bentonite that we had to show that we do not bind mycotoxins, or to a very, very low amount, only just a very low percentage. So it's important when you choose a product that it's proven and has a special focus here, that the people can show that nutrients and vitamins are not bound. And here I really want to point out that not all bentonites of the same quality and composition, and therefore it's really important to understand your product and also to know the composition of your product or your bentonite, to have no to have a defined binding and not a binding of nutrients and vitamins.
Sure. Certainly something to keep in mind then. So we have another question here, this time for Philipp. And we're getting towards the end of our question and answer session. So this one pertains to a physical check of physical feed. Is there any quick way to determine if you've got mycotoxin contamination?
Well, they are hard to see. No, you can't see them at all. And you cannot taste them as well. You shouldn't eat it to check that. But, well, the effect of mycotoxins is at a very, very low concentration, but the taste of it is not. So you can't sense it, but it still has a severe effect. Mycotoxins are produced by fungi, so one might say, okay, if I see a fungi, I can say, well, there's mycotoxins in there. If you don't see fungi, that's okay. That's not at all like this. It's possible that you have fungi which is not producing mycotoxins at all, and so you don't have a problem there, but it's also vice versa possible that you can't see the fungi contamination, but because the levels are so low of mycotoxins, there are mycotoxins present in a considerable amount.
Okay. So I guess then, in the absence of a physical method or a way to see them, you're then left with on-site options.
Exactly.
Or an analytical service.
Exactly. You have to apply for sure robust methods like we presented before, on-site methods, or you send your samples in. You have no other choice, actually.
Okay, that's good to know. Now, at this point, we're going to. I want to thank you again for all of the questions we've got incoming. They keep rolling in, and we're not going to be able to address them all today. Again, we will come back to you in the days ahead with answers to your specific questions. So thank you for those. Philipp and Simone, I want to thank you both for sharing your knowledge with us today.
Thank you, Ryan.
Thank you.
Nice to be here.
For those of you listening, you will receive an email in the next 24 hours that includes links to today's recording, the latest BIOMIN mycotoxin survey report, and the Romer Labs sampling guide. So please do look for that, and we hope that those tools to further improve and develop your mycotoxin risk management programs in your sites. Right before we close, I would ask each of you listening to do one thing for us, please, and that is to take a moment to share your feedback. It will take 2 minutes of your time to let us know how we did today. So your thoughts on the performance, the webinar, the topic, the content matter. That feedback will help us to improve in the future, and it will also help us to identify future topics so we can continue this conversation that is clearly important to the hundreds of you listening right now. With that, I want to thank you, and we are now closing the webinar. Thank you for joining the mycotoxin testing and survey results session today, and we'll hope to speak to you again soon.